You know what I think changed backup more than anything else in the last 30 years? It's not the cloud, it's not AI, it's deduplication. And if that mystifies you like most people, then this is your episode. This is the first episode in an Encore series where I bring back a number of our episodes from the back catalog that our listeners love the most. And not surprisingly, Dedupe bubbled right up to the top. What is deduplication and how does it actually work? We get into the difference between source dedupe and target dedupe, why your dedupe domain, which is the area that is going to be deduped together, why it matters a lot, and why I argue that file level dedupe really isn't dedupe at all. Just a quick note about me. I'm W. Curtis Preston, aka Mr. Backup, and I've been obsessing over backup, recovery, and now cyber recovery for over 30 years. If that's your bag, then I'm your guy. You're not going to find anyone that cares about backup more than me. Ever since 1993, when I had to tell my boss that there were no backups of the production database that we just lost. Now I've written 5 books, a blog, and a podcast. Here, we turn unappreciated admins into cyber recovery heroes. This is the Backup Wrap-Up. Hi, and welcome to Backup Central's podcast. I'm your host, W. Curtis Preston, aka Mr. Backup, and I have with me my network re-architecture engineer, Prasanna Malaiyandi.
Curtis, whatever I could do to keep you safe.
You know what's really funny is, like, I consider myself a pretty tech-savvy guy. And when we were talking today about what how I replaced a bunch of gear and I'm swapping out some stuff and moving some cables around. And then you were yelling at me. You were like, you can't do that. You can't put the switch on the thing. And I was like, you can? What are you talking about? And it took me like a couple of seconds. And I was like, oh, wait, you're right. I can't do that. I can't put the switch. I can't put the router that's going to be my firewall on the same switch as
your device
home LAN.
Yeah.
I don't know what I was thinking. Yeah.
Just on another topic that I know just a little bit about.
I feel a little ashamed. But I'm glad I talked to you, as is the case with many subjects. I'm glad I talked to you about what I'm up to.
Glad I could help.
I have successfully purchased, for the video watchers, let me see if it makes it into the camera before the cable runs out. There it is, the Asus AX600. It's a mesh router, and I got to say, it's much more better than what I had before. And it's able... it's supposed to provide 5,500 square feet, but of course that doesn't include drywall and 2x4s, right?
Yeah, it's crazy how much signal degrades going through drywall.
Yeah.
And the other thing people don't realize is 5 gigahertz like degrades like no tomorrow.
Remind me why 5 gigahertz is better.
It's faster because it can handle more bandwidth and also the channel is wider. So you can have more things talking at the same time. It's just as your frequency goes up, the distance goes down for the same power levels.
Right. So is this like DC versus AC?
Not quite DC versus AC. It's more about you need to pump as many things as possible into, because high frequency, it's more per cycle than 2.4, which is less airtime, if you will. Yeah. And so every sort of peak, you can send more out with the 5 gigahertz because you're doing it more often. And so it works a lot better. It's just the distance isn't as great. Now, I will tell people, so this is I'm going to get up on my soapbox now, right? One of my rare soapbox events, and tell people, a lot of times people think they need more Wi-Fi access points in their house to get coverage. Mm-hmm. And to those people, I will say, plan out your network carefully, put your devices where they matter. Mm-hmm. And also don't put too many devices and don't crank up the power all the way to high, because I know, Curtis, you and I were talking about this when you're looking at mesh, and it was like, Imagine that your router can overpower your phone, your laptop, your iPad. So it's screaming at the top of its lungs, and your phone can barely even scream back at it. And so that's actually worse for your network and
Mm.
for airtime than
I
actually balancing out power.
I just don't know if the stuff you're talking about, like, is that even is that configuration option even on consumer class routers?
You'll have the low, medium, high power levels,
Mm,
but it takes time to fine tune and tweak these, right? You have to walk around with a Wi-Fi analyzer on your phone, right? So
mm,
Apple with their iPhones, right? They ship, what is it, Airport Utility, which has a Wi-Fi scan option,
right.
which will show you all the Wi-Fi networks and their signal strength. You basically have to walk around your house with that and be like, okay, where is it strong? Where is it weak? To figure out the placement. That's the ideal way, because what you want is you want coverage in the right places. Because what is in a lot of high density housing areas or even homes next to each other is most people end up with crummy Wi-Fi because their power is turned up so high it bleeds into everyone else's area, such that everyone has a crappy time. Because then you get interference and then everyone slows down and then it
Yeah, I got a lot of Wi-Fi. I got a lot of networks. Yeah.
And for the last bit of my soapbox is, please do not use 40 megahertz channel widths on your 2.4 gigahertz channels. You do not need to use 40 megahertz and ruin everyone else's connectivity. Please only use 20 megahertz bands for 2.4 gigahertz.
I'll see what I can do. But I have this new, and again, I am not a wireless, I feel like a wireless noob, but I have this new fancy, right, where it automatically selects
Mhm.
the right. That's
Access
pretty
point to,
cool.
yeah,
Yeah. Not just
and
that, but also
the band.
2.4 versus 5.
Yep.
Yeah.
So actually, all of this is part of the Wi-Fi standard. So the figuring out which access point, that's part of the 802.11r standard. And I think that the band steering is also part of the standard as well,
Yeah.
that a lot of folks are implementing. Now, some devices don't do well with band steering. It basically looks at sort of the difference between the 5 gigahertz and the 2.4 gigahertz and says, okay, which one should I pick? And most devices, if it's 7 decibels difference or more, then it'll pick the higher, the faster speed.
Hmm.
And so that's how it tricks your devices into picking the right band.
Interesting. Yeah, it's cool. All
It's
I know
magic,
is
though.
I finally have a mesh that covers the two, because my problem is that I have things in the garage, things embedded inside walls in the garage that need Wi-Fi, not just inside walls. I have a device that's inside a wall, inside an electrical cabinet, inside a wall. I have a Sense app
Definitely.
or a device, and that's deep inside my circuit breaker box. And this reached to it no problem. It had 2 bars. So clearly, the thing is, it's only 20 feet from here,
Yep.
but it's a couple of drywall walls and some
And,
2x4s
yep.
and some metal, but it worked. That's the important part, is that it works. Yeah. So I think I might be in Wi-Fi heaven for a while.
Woohoo!
And you too can be there for the low price of $350. That's a 2 node system. And it's yeah. But I'm pretty happy. But that's not what we're talking about today.
Really? We could talk about Wi-Fi all day if you want.
Yeah, you could talk about Wi-Fi all day. I feel really stupid when you're talking about Wi-Fi, because I'm like, this is not my bailiwick. That's a cool word, by the way, bailiwick. So I thought we'd talk about backups instead, because that's my world. And I feel comfortable knowing that most people don't know crap about this space, because they get the job as a junior person, and then next thing you know, they become a real sysadmin or a network admin or a security admin or a DBA.
Yeah. Except our listeners, who are all awesome and probably experts in the backup field and know all about this.
Well, certainly Daniel.
Hi, Daniel.
Hi, Daniel, the backup anorak. I wonder, he better still be listening to the show, since we call out to him every once in a while. Him and Stuart. Although Stuart's retired. I don't think Stuart's listening to our show. I only tell him when we talk about him. But so we're continuing in our Backup to Basics series. It's been a couple of weeks. As the kids say, it's been a minute since I remember the first time I heard that thing, I was like, what are you talking a minute? Anyway, but yeah, it's been a minute since we've done an episode of our Backup to Basics series. but I am looking down at the book. And of course, for those of you that don't know, basically, we're doing a podcast version of my book, Modern Data Protection. Make sure I get to the camera here. From O'Reilly. You can purchase the print version from your favorite bookseller. Perhaps it's one based in the Amazon, perhaps not. And but if you would like an ebook version of it, you can get your own by going to druva.com/ebook. That's druva.com/ebook. They will, of course, ask for your contact information and then email the crap out of you until you tell them to stop. But that is the price that you. Let's talk about. And while we're at it, I'll throw out the disclaimer that this is an independent podcast, and I work for Druva. Prasanna works for Zoom, but the opinions that you hear are ours, and etc. Please rate us by going to most of you are on iTunes. Just scroll down to the bottom there, give us 5 or 6 stars, and a comment. We love comments, and if you'd like to join the conversation, just contact me, wcurtispreston@gmail or at WCPreston on Twitter.
What about LinkedIn?
Oh, yeah, LinkedIn. It's linkedin.com/in/Mr. Backup. And by the way, my Twitter account already has multi-factor authentication configured, not using SMS, which, as should you, especially now that they're disabling. So weird the way they did that. What's funny is I support the decision. It's just the way they did it. The way
it came out. Yeah.
Oh, Elon. Okay. So in our Backup to Basics series, we're continuing on. Today, we are talking about using disk deduplication. A couple weeks ago, I hit 30 years in the backup industry, and I got interviewed by Chris Meller.
The Register, Blocks and Files.
Yeah, and for his Block and File blog. And one of the questions was what I thought was the most important development in the backup industry since I joined. And to me, hands down, there's not even a close second, and that is the invention of deduplication.
Yep.
And because I can't think of another technology in the backup space that has changed backup architecture more than deduplication. And I can think of many other things that we do that are only possible because deduplication is underneath them.
Oh, yeah, definitely. Yeah, I don't think we would be able to get, especially with the data growth and the size of these applications.
Is data growing? Is it?
No, not at all. I don't think it would be possible to do, like, I know, Curtis, you've talked about previous, like in your early days, about trying to do a backup and being like, oh my God, how am I going to do this full backup in a weekend? Right?
Yeah.
And just with the fact, and I know we'll go and talk about more about deduplication, but yeah, just being able to now do that in a cost-effective way using new ways of actually doing the backups as well, which is enabled with deduplication.
Yeah. So it's like disk. You could argue that using disk in backups is the bigger advancement, but first off, not really an advancement. It's just, instead of tape, we're going to use disk.
Which was there to start with anyway. It was just the cost was so high.
Right.
And especially given the type of workload with deduplication or with backups where you're doing periodic fills or other things like that and keeping them for long periods of time. Are you going to spend 40x or 30x on storage for your backup system versus your production? That's a hard sell.
It just, because that's the problem. So one of the things that I remember from back in the day, like I don't remember really thinking about this lately, but back in the day, I would say that for every gigabyte of primary storage, you had 20 gigabytes of backup storage. And so if you're going to do that with disk, even once many years ago, wow, at this point, it's 20 years ago. But even once they came out with this idea of using SATA disk instead of
or nearline storage,
that helped bring the cost down significantly. not as much as deduplication.
Yeah, because even with those price differences, right? Maybe it was half the price or a third of the price, but once you add in that 20x that you talked about, Curtis,
Yeah.
then that
Yeah.
adds up. And it's not only just the storage cost, it's also you have to account for the power, the cooling, the floor space, right? All the things that go into that system.
Yeah. Yeah. It's funny, just an afterthought, that post that Chris Meller did about the 30 years, the one group that jumped on the article and just started retweeting all kinds of parts of or pieces of the article was the tape group, because I said really good things about tape. And the thing is that I believe in all of those things, but all of the advancements that I've seen in backup in the last 20 plus years has been disk and deduplication. So let's talk about, so not everybody really understands what deduplication is. Some people used to describe it like it's like compression. The way I remember, it's like macro compression. It's like compression over
Yeah.
time. What do you
Well,
think of that?
I don't quite like that. So
Maybe some old blog posts
yeah.
that I might have said that phrase. Go ahead.
So in my mind, deduplication is finding two identical segments and tossing one away, keeping only one copy, but still
Mhm.
keeping a reference to that. So you still know you have two virtual copies, but one physical copy.
Right.
At
And
a high level,
what
that's
is
what and now
compression for you?
what is compression is taking an object, a singular object, and squeezing it into a smaller space.
But how? Do you understand how compression works? Because I sure as hell don't.
Yeah. So you typically like you would run it through different types of algorithms like LZ compression and all the rest in order
Right.
to look for patterns and throw away bits and compress it down. Now, the difference I would say between dedupe and compression, because they do sound the same,
Yeah.
right? I would say one of the differences is with deduplication, it's more like a file system level compression, if you want to think of it that way, because it's not just
Well,
I'm
that's why I
taking this
said
block.
macro.
Yeah. It's not just I'm taking this and I'm squeezing it down such that it could be, I just need to look at this and figure it out. It's a lot more complex than that.
It is
Right.
definitely a lot more complex than compression. I've just honestly never really dug into the code of how traditional compression works. So the idea is that I'm looking for duplicate segments of data across many places, both from different sources as well as different time periods, right?
Yeah.
I'm comparing this chunk of that's coming in right now in tonight's backup. I'm comparing literally with every chunk of data that I've ever received from
It,
anywhere else.
I would say that's an ideal system, but not everyone builds their deduplication that way,
Yeah.
where
So
it's
there
in,
are,
yeah.
go ahead.
Yeah. So it all goes down to what is your deduplication domain is another term that some people talk about, right?
Yeah.
Which is it limited to a system? Is it limited to a cluster, which might be formed of multiple systems?
Right.
Or is it limited to a single backup stream coming in? Right.
So
So there
is
are
that the question is, what is your data domain?
dedupe domain.
So let's back up. So as I understand it, right? So basically we're taking the data that's coming in or that's going to come in, we're slicing it up into, I like the term chunks, right? We run those chunks through a cryptographic hashing algorithm, SHA-1, SHA-256, whatever you're using. On the other side of that, we get a alphanumeric value. In the case of SHA-1, it's 160-bit alphanumeric value. So basically, depending on the algorithm you use, you get an alphanumeric value at the end, and the size of that value is going to be based on which algorithm you use. In the case of SHA-1, it's 160 bits, right? And you can then take the 160 bits. You can't reverse engineer it. You can't take the 160 bits and turn it into the chunk, but you can use that value to uniquely identify that chunk. And so if you have another chunk of data, regardless of where it came from, if it's 160-bit value, again, that's SHA-1 and other values are different. If it's fingerprint is the same, you can say that this chunk is identical to that other chunk that had the same fingerprint. And you can then discard the other chunk, right? The new chunk.
You can discard the actual data, but you should still keep track of it somewhere
Of course.
in a file system, just because you still need to.
Yeah, you're going to keep track. Oh, we found another one of these, right?
And so usually that lookup is in a deduplication index, is what they call them usually, a dedupe index, right? Which keeps a list of, hey, here are all the fingerprints that I have.
As we were alluding to before, one of the things that determines sort of your effectiveness of dedupe is the dedupe domain, right? So I've seen it file system level, meaning it only looks for duplicate data within each volume. I've seen it host level. I've seen it backup level, meaning literally backup configuration wise, right? So if I have a Windows server and I'm backing up the host and I'm backing up SQL Server, I only look for duplicates within SQL Server backups, right, against each other. Then we have, if we're backing up several systems to a box, right, maybe that the dedupe domain is only within that box. It's only looking for duplicates between all of that. And then there's what I would call truly global dedupe, which is we're looking for duplicates from everything that's coming in from multiple sources. There is a point of decreasing marginal returns, right? You can argue, and certainly if you're a company that only does dedupe within, like earlier, we only look for dupes within SQL Server backups. You could make an argument that there's not a lot of duplicate data between SQL Server and Windows, right? So even though we're not comparing the two, there's not going to be a lot of duplicate data there, and there's not going to be a lot of duplicate data between the SQL Server database on this host and the SQL Server database on that host. So that's another argument that some make.
But I think a lot of that was because of architectural limitations of the products themselves, rather than that is really what you wanted to do, because that's more of a management issue.
They didn't. It was like, if we're going to do it that way, it's going to be much harder to design a product to do it that way. And we don't think that there's going to be that much more benefit.
But on the other hand, if you look at things like VMware, right? If I have a bunch of VMs, there's a good chance, and they all came from a single golden image, right? There's a good chance that as you're backing it up, 80, 90% of that stuff is all going to be deduplicated. Right?
Absolutely. Absolutely. There's also a lot of duplicate data, even within a large filer, right? There's going to be lots of duplicate data there, right? So if you're only doing it volume to volume or backup configuration to backup configuration, there's a lot of duplicate data that I think you would miss.
Yeah. I know you talked about the domains, but I think another thing to also mention is some products do different types of chunking, if you will. Some do it at the file level, others do it at a smaller level, right? And some do fixed segment where each one is a fixed length. Others do variable segments where they try to figure out what is optimal. Because depending on how you're doing your fingerprinting, you want to find the most number of matches, right? So you can save on storage. And another thing that also comes up.
I would argue that file level dedupe isn't really dedupe. It's more a single instance. That's like single instance storage of a file. Okay. But so I'm always thinking subfile when I think about what I think of actual dedupe. There is a very big other way that we divide up the dedupe industry, and that is source versus target.
Yep.
Right? The first dedupe product I ever saw,
HydroStore,
which was not the first. No, the first one I saw, the product at the time was called Undo.
Interesting.
Undo with 2 O's. It was really funny that the name of a dedupe vendor had duplicate data in their company name. It was Undo with 2 O's. You know this product. You just don't know that's what it used to be called.
What is it?
I'll give you a hint. The name comes from the fact that it would be a sea of availability. I'm gonna put the Jeopardy theme in here.
What would it? Sea of availability.
Sieve, that's where the name for the company comes from. Or if I want to put it in the right order, an availability sea,
I don't know what this is.
Avamar.
No, that makes sense.
Yeah. So that's where the name Avamar came from. So the first source.
I should know that.
You should know that.
Being part of my former employer. Yes.
Yeah. I have a bit of an inside track because they were right up the road from me, right?
Yep.
They're up there. They were up in Irvine. And that was the first Dedupe product. They were a source Dedupe. So what's the difference between source Dedupe and target Dedupe, Prasanna?
So the biggest one is, so let's first talk about target dedupe, right? So target dedupe is data comes into the system and then a deduplication algorithm runs, tosses away data. It can support any type of client as long as it supports whatever the protocol it has. So if it's NFS or SMB, right? Whatever can write to it, the data gets deduped.
Hang on, before you go on to that. I don't disagree with what you said. I think there could be a little bit more clarification. It's a box that I send whatever I want to, right? Typically, the thing about target dedupe was that it was, you didn't have to do a lot of re-engineering of your backup system, right?
It's like a VTL system, right? That came in.
Plug in a box, yeah, and you would send. It's basically you stopped using tape and you sent your backups to this box. Maybe the box might even be pretending to be a tape library, virtual tape library, and did all the dedupe magic over there. Yeah.
Which was great because you can just plug in your box and go.
Yeah.
Now, the other side is called source side dedupe. Instead of sending all the data and tossing it away, why don't we do something smart and actually figure out the duplicates on the client itself, on the source, right? Dedupe on the source and only send the unique data. And this has the advantage of actually not sending the data over the wire, which is actually a huge benefit that people don't understand always, right?
Yeah.
Is not sending the data can actually make it a lot faster, even though you think, oh, I'm now putting additional load on my server itself, but it ends up being better than trying to send all the data and just tossing it away like target side dedupe does.
I would say it theoretically should be better, right?
Yeah.
Because I'm just saying I've seen some crappy source dedupe systems, right?
Okay. Sorry, I've seen some good ones, or the ones that I've interacted with have been good, and so I've seen the performance numbers around turning out.
I do think it makes more sense to me. It always made more sense to me. The only reason why we had target dedupe was because to do source dedupe, you have to redesign the backup product, right? It took a long time to get, basically you have to stop using NetBackup Network or TSM, whatever it was back in the day, and you had to replace it, like in this case with Avamar. Avamar was a source dedupe product. You had to do what we call a forklift upgrade. You had to throw out the baby with the bathwater, whatever analogy you want to use there. That was the main problem as I saw it with source dedupe, is that you had to change your backup product to get it.
Well, but that was in the beginning, right? At the very early.
Now you just had to upgrade your backup product, right? Yeah. Because many of modern backup technologies now support source dedupe. Although even some newer backup technologies don't. I don't know. I don't know if that came out in English. There's some double negatives in there. Some newer, very new backup technologies don't do source dedupe.
Which seems bonkers.
Which does seem bonkers. I'm talking about the likes of Rubrik and Cohesity, right? These are next-gen backup products that were designed in the last 10 years. And it's based on an appliance model. And they do all the dedupe inside that box, is my understanding, right?
And I just want to challenge that, Curtis, because I thought in some cases they do source side deduplication, but I think because they've tried to be open and act as a target device, in those cases you don't really have another option.
I don't work at Druva, not at Rubrik or Cohesity, but it is my understanding that they do target side dedupe, and one of the challenges of target side dedupe is you need an appliance at each location. Now, I know that they can do virtual appliances, right? So they have a VM level appliance, but you need a box or something pretending to be a box at each location, because if you're not eliminating the duplicates before you send it to the box, you need something that's on-prem, right?
Yeah, because you definitely don't want to send that all over the WAN.
No, to me, that's the biggest advantage of a source dedupe system, is that it's ultimately scalable, right? That assuming it doesn't slow things down, assuming all these things, assuming that the product actually works, that you can back up a laptop, right? You can back up a mobile phone, and duplicate data would be eliminated before it's sent over the WAN, which is what you need to do if you're backing up something over the internet. And so the downside that again, you talked about it already, is that it does put additional compute requirement on the client. But the argument is that it's offset by the savings of the network.
There is also one more downside.
Okay.
Which is that not all applications can do source side deduplication. So if you do have an application which only supports writing to like an NFS mount point or an SMB mount point, or something that doesn't allow the integration of these or source logic, then you are going to need to be able to support target side DD.
Yep. Agreed. And an example of that would be like Oracle, right? Right.
Incremental merge.
Yeah. Although I would think that you should be able, I don't know, we can talk about this all day.
You can't.
You can't take the Oracle stream and slice it and dice it? I don't know.
You could. There are companies out there which provide a virtual file system interface that lives on.
So you fake it. You fake it out.
Yeah.
Yeah. Okay.
Yep.
All right. I've got something called hybrid dedupe, and this was invented by your former employer.
I don't even know what a hybrid dedupe is.
It's target dedupe pretending to be source dedupe. It's Boost.
Dedupe. Oh. See, here's my problem is I think Boost is source side deduplication. I don't know if I would call it hybrid because it is very similar to what Avamar did, right? It's moving the deduplication logic to the client such that you could do all of the computation, the same thing that we have talked about with source side deduplication.
I'll tell you why I put it in a different category. To me, hybrid dedupe is redoing the backup software. I'm sorry, source dedupe. True source side deduplication, it's done at the backup software level. Okay. Right? With hybrid dedupe, I'm still dumb sending everything to this source dedupe thing that's going to redo it, right? It doesn't matter. In the end, you get roughly the same benefits, right? That's what.
Okay. So with hybrid, you get the benefits of source without having to upgrade throw away your backup software.
So I spent most of this time talking about dedupe. There are a bunch of different ways to use disk in your backup system, some of which don't really require dedupe, right? We used to do what we call disk caching, where you just had enough disk for last night's backup. You would back up to disk, and then you would copy that to tape, and then you would hand that to a man in a van. Then we got a bunch of different things. I got D to T, D to C, and D to C. I do all that. So disk to tape, disk to disk to disk, direct to cloud, and disk to cloud, right? So these are all ways that people use disk in current backup systems. To me, D to C or disk to cloud is really disk to disk. It's just the cloud the disk is being run by the cloud, right? I will say that dedupe, by the way, without dedupe, the whole thing of using the cloud the way we use the cloud just wouldn't work. You can't send full backups to the cloud. You could with unlimited bandwidth.
Well, and with unlimited bandwidth, it would just be expensive. Just going back to the conversation we had earlier about the WAN, right? You don't want to send full copies out over the WAN,
right?
Because that gets expensive and very slow. The other one I was going to comment on was, I know we've been talking about disk, but I think it's also important to acknowledge that now it's no longer spinning disk. It could also be flash. Right? We've seen.
Yeah,
I
but
know.
that's a
I
whole
know.
other thing.
Yeah, I know, but I'm just saying that when it comes to deduplication and backup or protection storage, right? It could be flash, it could be disk, it could be object storage, right? So I think it's important to differentiate that, like what we're talking about with deduplication when we mention disk, right?
Yeah,
The
we could
media
call it
layer
not
itself.
tape.
Yeah, the media layer. Yes, the media layer is not tape.
Hang on one second. I didn't realize I had a meeting here.
Meaning at 4.
Yeah, 4:15, which is an odd. All right. It's a pre-meeting with a podcast thing. It's yeah, okay. I hate
Just
to be a flash
I know.
and backup,
I'm
but
just saying that people will bring it up, so I just want to clarify that
yeah,
when we talk about disk, we're just talking about not tape.
only place, yeah, correct. The only place where I think maybe Flash has a place in the backup system is the folks over at Pure, and they're all mad at me now. But the only place where I think Flash has a place in the backup system is with like live recover stuff, right? If you're going to do instant recovery and you're actually going to run VMs off of your backups, that better be some really nice performing disk. But the thing is, it doesn't need to be your whole system. It just needs to be like the most recent.
A part of it. And it needs to, you don't need your entire system to be flash, right?
Yeah,
You just need enough to be able to support that use case.
I just think that where Flash does really well is in random access, right? Backup isn't a random access application. Backup is a streaming application. Even if what we're talking about is large dedupe chunks, I don't know.
Yeah.
Let's just say the jury is out for me. I am in Missouri. Missouri? Is that the show me state? That's the show me state.
Yeah.
Yeah. So I tell you what. If there's anybody that's listening to this that just got pissed off,
what's his name? I'll come back on.
I welcome you to come on and tell me why I'm wrong.
I know who will come back on. You know who?
Who will come back on?
What's his name? Fast Data Guy.
Oh. Are they Flash?
Yeah.
Mark? No, sorry, Howard.
Howard. Yeah.
Yeah. It's
Fastest pure Flash. Yeah.
Yeah. All right. Yeah, Howard, you want to tell me why I'm wrong? I'm more than happy to have you back. We can duke it out. Wouldn't be the first time Howard and I have disagreed on something. I don't know. It's just there are so many other places where I would want to spend money in the backup system.
Yeah.
And
it comes down to what the cost is. If you could get Flash down to a low enough point,
which is the point of VAST data, right?
Yeah.
Their architecture allows using Flash in a significant way.
Yeah. That's why I brought it
close to cost. Okay. All right. Yeah. Okay. All right. All right. All right. And this whole other thing, I'm not going to go into the thing. But yeah, so Dedupe makes disk and cloud-based products both physiologically feasible as well as economically feasible. And
is there something that a person shopping for a Dedupe system should be asking? What are the important things that they should be asking in order to determine sort of?
That's a great question. I think the question would be things about what's the restored performance, because in the end, that's the only thing that matters. I remember a product. Now, this product is still on the market, but I believe they have addressed this issue. I remember a Dedupe product. It was a Target Dedupe product that had 400 megabytes a second throughput in to an appliance.
And like 10 megabits out?
It was 40 megabytes out. It had a 90% what we call dedupe tax. Because the problem with dedupe, depending on how you store it, is that you everything you need all over the place.
All over the place.
Yeah. And so this was really bad design. And I believe that they addressed it. And because that product is still on the market today. But version 1 of that product was horrible.
Yeah.
So it's about restored performance, right? So one thing, dedupe ratio is crap. Don't look at dedupe ratio. Dedupe ratio is a made up number. I'll pick on Avamar. Avamar back in the day used to say they had a 400 to 1 dedupe ratio. Do you remember this? Because it
I
basically
remember.
considered every backup as a full backup. They're like, the way we store backups, which is the same way Druva stores backup. The way we store backups, it's even though they're incremental, it's like they're a full, right? Because they behave a full during a restore. And so they considered every backup a full. And so they said, well, therefore, the dedupe ratio is 400 to 1. That was always complete nonsense. The other would be, I remember, again, I'm going to pick on people equally. I remember sales reps of a certain large target company where you might have worked, where they would tell customers to go do full backups more frequently because it made their dedupe ratio better, which is just, again, nonsense. What matters, in my opinion, is how big is a full backup versus how big are all the backups, right? So I'm saying, if I have 100 terabytes, if one full backup of my environment is 100 terabytes, and after 3 months, how big is, or whatever number you want, but it's just 3 months seems like a nice long, what do you call it, a C thing, right? After 3 months, how much stuff is stored over there? That's what I'm saying. Dedupe ratios is nonsense. That didn't come out in English. Dedupe ratios are nonsense. But if I can fit 100 terabytes, if I have a 100 terabyte environment and then a series of incremental backups, and then over there, my question is, how big is that? How much data did I write to disk? And let's say it's 200 terabytes after 90 days, and then compare that with another product who writes 100 terabytes. You backed up the same data, but you used half as much storage on the back end. That's what I'm saying. The problem is, and the other reason, and again, I'm a little extra sensitive to this because I work for Druva. People ask us, what's our dedupe ratio? We're like, the thing is, we're like the opposite of Avamar. We're actually similar to Avamar in that we're source side dedupe, but we don't use that funny math. So we could say 400 to 1, but that's nonsense. So, we say because we also do incremental forever backups. That's the problem. But know that on average, if we have a 100 terabyte customer, we store roughly a year's worth of backups in less than 100 terabytes of disk.
Yeah.
Right?
And I think it's important there to also account for that increment. Like how I look at these like numbers, I totally get what you said, Curtis. Like you should just do an apples, but
Yeah.
if you don't have that ability, you should also look to say, okay, I have 100 terabyte full, and then say my daily change rate is 2%, right? So if I do 2% for a month, right, that's, what is that, 260, 60 more terabytes, right? So it should be 160 terabytes worth of data that I sent over, right? For 160 terabytes worth of data, how much should I actually store? Which will give you similar things to what you're saying, right?
Yeah.
But because what you're saying is, if you had the two products, then you could do a direct comparison. But I'm saying if you don't have the two products, then here's another way you could look.
I would argue that there's no way to compare them if you don't have two products. If you're not doing a true comparison, it's just the dedupe math is funny, right? So different products charge differently, right? You look at, like when you look at Metallic, which competes with Druva, they have a front end price and we have a back end price. They actually have the front end price, and then you also need to pay for the back end storage. So you're paying. So how do you compare that? It's difficult.
It's hard. Yeah.
It's hard. But all I'm saying is dedupe ratio is crap. It doesn't mean anything. But what does matter is how much data are you storing on that back end, because you will be paying for that one way or the other. All right. If we made this, if this is clear as mud or what, but I hope that was helpful. And maybe we ticked off Howard, and Howard's going to come on next week's episode.
Come join us, Howard.
Thanks for helping me with my network as well.
Anytime, Curtis. Just remember, I am not tech support.
Yeah. All right. And thanks to the listeners. And remember to subscribe. The Backup Wrap-Up is written, recorded, and produced by me, W. Curtis Preston. If you need backup or DR consulting, content generation, or expert witness work, check out backupcentral.com. You can also find links for my O'Reilly books on the same website. Remember, this is an independent podcast, and any opinions that you hear are those of the speaker and not necessarily an employer. Thanks for listening.